okay, where the drain comes. So this is the pre-replacement. Okay, pre-replacement, the replacement which we are infusing before the filter. So this is a dialysate scale in green color, and this is the post replacement.
This is where the citrate was given.
Yes, the same pump. Okay, in the pre-replacement, this is work as a pre-replacement pump as well as the citrate pump. Okay. Then this is dialysate.
Suppose we are not using citrate, then what?
So we can hang a Prismaflex solution, same dialysate solution, the same concentration we can hang. So that will work as a pre-replacement. Okay. And it's a pre-dilution also. It will dilute the blood and it will goes into the filter. Okay. So then there are 4 more pumps. Okay. These 4 pumps will control these 4 scales. Okay. So this is for the effluent, to drag the effluent from the filter or from the dialysate compartment to the drain bag. Then this is for the pre-replacement or the citrate to take from here and to deliver in the before the filter. And this is for the dialysate, to collect the dialysate and give it to the dialysate compartment to dialysate it. This is for the post replacement, which will collect the post replacement and give it to the after the filter. Okay, these 4 pumps. Then we have pressure ports. So as we know, in our HD machine we have 2 ports, one arterial pressure port and venous pressure port. Okay, so our ultimate need is to for the patient safety. Okay, to measure the pressure. So we have 1, 2, 3, 4 and 5 pressure ports. Okay, so I will tell one by one while connecting that. Okay, this is the access or the arterial pressure port. This is the filter pressure port. This is for the effluent and this is for the return. Okay, this we are not using for the CRRT. Okay, some other the tech core we can here also we can, there is an option. Okay, then this is the blood leak detector to detect any membrane rupture that will detect from here. Here we can put that effluent line. Okay, then this is a discharge ring, to avoid that static electricity, to avoid any ECG variations and all. Okay, like earthing. Then we have that deaeration chamber. Okay, that holder. Okay, then here we will keep the deaeration chamber. We have only one deaeration chamber. In HD there are 2, before the filter as well as after the filter. To minimize the blood volume, we kept only one deaeration chamber in the circuit. Okay, this is the air detector. So this is the clamp. Okay, if any air detected, the further flow we need to stop. So we have a clamp. Then this is the syringe pump. Okay, so this we can use for the heparin infusion. At the time of citrate anticoagulation, this will be converted as a calcium replacement pump. Okay, if we are using this pump for the calcium replacement, this line will directly go to the patient, not to the circuit. Okay, for the calcium. If the heparin, this will go to the circuit. Okay, this is a warmer.
Citrate that will calcium chloride will be used.
That we can use both, but the dose will be different for both. Okay. So in the machine itself, we can set whether we are using calcium chloride or calcium gluconate. Okay. If we have option of external calcium delivery also in this machine itself, I will show you. Okay. Then this is a warmer. Okay, this warmer we are using. Okay, as we know in the HD machine, the dialysate warms. Okay, there is a heater and so, but here the dialysate will come as a ready-made solution. So the blood will become warms. Okay, the return blood is there. The blood which is going into the patient will be warmed and sent to the patient. Okay. I have CBB HDF, CBB HD, CBBH, and SCUF. Okay. So as you know, in the SCUF, we have slow continuous ultrafiltration. No need of dialysate and replacement. Ultrafiltration we use. Then in case of CBBH, continuous veno-venous hemofiltration, we use convective clearance. Okay, so we need replacement solutions. We need a pre-replacement as well as post-replacement. Okay, in CBBHD, we use for the diffusive clearance, we need dialysate. No need of these pre and post replacement. In SCUF, no need of these 4 scales. Okay, because only the negative pressure or ultrafiltration we use. Okay. So we have a switch here. So this machine has so that means we have to end the treatment. Then here the switch. So for this machine, one power cord for this warmer, one for the machine. Okay, it's a separate. Okay. one from the machine, one from this one. Then we can switch on from here. Hello, Abdul. Prismaflex is a software based. Okay, if it is our usual HD machines, once whatever the function is there till the end, that only that much functions. Here we can update the system. Like our phone, we can upgrade the software. Okay. Earlier that citrate was not available in the citrate option. Once the citrate consumables available in India, we are upgraded that version. Like that we can keep up. Now the latest version is 8.2. That is free of cost. Our engineers will come and upgrade. While switch on, we have the screen. We have two options. One is therapy information and continue option. So this continue option, for starting a therapy for the patient, we have to click on the continue. In therapy information, for the academic purpose, to understand this machine. So here all the therapies will come. In this machine it is not coming. Usually in all machines, CRRT, hemoperfusion, then Mars and TP, all four options will come. If you are clicking that, we will get a small description what are the bags which is used. Okay, only for the academic purpose. Okay. Then for patient, we can continue. Then here we have new patient and same patient option. If you are starting a new patient, you can select this. If you are doing a therapy for the same patient, because already we are entered a therapy in the morning, for the same patient we are starting a therapy in the evening, we can use this same patient, the same prescription settings will come. Okay. So now I'm using a new patient. In new patient, battery is not. Okay, in new patients, the machine will ask three details of patients. One is patient ID or patient name, then patient weight and patient hematocrit. So here I give patient name, whatever, either name or ID, enter. Then patient weight. To calculate the effluent dose and all, we need the patient weight. So it is 60. Then we have a hematocrit to understand for calculating that filtration fraction and all. Okay, so 30 is default, it comes 30. If it is different, we can set it 33. So these are the three values I given: patient ID, patient weight, and patient hematocrit. If it is correct, we can confirm. If it is not correct, still we can change whatever we need to change. Okay, I'm confirming. Then here we will get the therapy, which therapy we need to select. Usually all the therapies will come here, only CRRT. In CRRT, as I said, we have four modalities: SCUF, CVVH, CVVHD, and CVVHDF. So the usual doctor prescription will be CVVHDF only. So if we are choosing this CVVHDF during the therapy, we can change to any of these therapies. Okay, if you are selecting the CVVHD, if you want to change, come to degrade to CVVHD, you can just decrease the, just make zero the replacement or substitute. Okay, then it will go to the HD.
Reverse is not possible.
Yes, if you are making zero this dialysate, that will become CVVH. If both are zero, our replacement as well as dialysate zero, it will become SCUF. Okay. In case if you are choosing this CVVH here, then you can come to SCUF, but not to CVVHD or CVVHDF. So better to choose CVVHDF, the highest therapy. I'm choosing CVVHD. Then we have anticoagulation options. Okay. In anticoagulation, we have three methods. One is no anticoagulation, the other is systemic, then regional. So in no anticoagulation, we are not using citrate or heparin. So in systemic, we use heparin. We will use this syringe pump and we will give this heparin infusion before the filter. Then we have citrate option, that is regional anticoagulation. In citrate, we have two options. Okay, as we know, while giving citrate, we have to replace the calcium to the patient. Okay, we can use two methods. One is we can use this syringe pump for administering that calcium, or we can use an external syringe pump. Okay, if we are using external this syringe pump, we will select citrate anticoagulation and calcium delivered by Prismaflex syringe pump. And the second option is citrate anticoagulation and calcium delivered by external syringe pump. In both cases, that line will directly go to the patient. Okay, not to the circuit. Even we are using this one also, that line will be extended to the patient. External syringe pump means directly we can give to the CVP or something. Okay, so I can choose which one, which option?
Citrate.
citrate.
Prismaflex.
Prismaflex.
Okay. Then machine is saying you have selected this option. You can confirm that. Then till now we have selected the therapy is CRRT and the modality is CVVHDF. The anticoagulation is citrate. Okay. Here regarding that citrate bag we are using, that is common. It is already fixed in this machine. 18 millimole is the concentration of Regosit. The bag is called Regosit in India. Outside it says Prisma citrate. The concentration of citrate is 18 millimole per liter. Then calcium we are using in this machine. It is choose is calcium gluconate, and the concentration is 220 millimole per liter. Okay, in liter it comes 220. Okay, then we can continue here. Okay, so we are till now we did the patient details. We are given patient name, weight, and hematocrit. Then the therapy we chosen CRRT, and the anticoagulation is here. The modality is CVVHDF, and anticoagulation is citrate. Continue. Then now we have to attach this filter into the this machine. Okay, now we can attach the filter and press load. Then the pump second will become fixed in this. Okay, so before that machine showing some steps. Okay, how to connect this. If he knows, we can do that. No need to, nothing will happen if I am pressing here. No functions, only the load will work. For the understanding or for the guiding us, we have these steps. Okay, so I will show you the filter how to connect. This filter, this is a Prismaflex M100. We have multiple types of filters. M100 we have, M60 we have, HF20 and Oxaris. These are the 4 filters available in India for CRRT. So M100 is the adult filter. Okay, so surface area is 0.9. The volume in the blood, including the dialyzer and the tubing, is 152 ml. Yes. Okay. Then we have M60. In that it is 93 ml. In HF20 it is 58 ml, including the dialyzer. That is for the pediatric patients. Okay. Then Oxaris, as you know, it's a sepsis management plus CRRT. We can remove cytokines as well as endotoxins plus along with the CRRT. So in this, actually, this is for the technicians, but still I will show what all these lines. So we have a red line. Okay, this is called axis line. So we have a blue line that is called retinal line. Okay, usually in HD they say arterial line and venous line, but in this machine any alarm which is related to this line, that comes as axis line alarm, and this is retinal line. These are the lengthiest lines in this filter. Okay, then we have 4 more lines with color coding. So this axis line is red in color, retinal line is blue in color, and this is for the effluent bag. Okay, this will collect the effluent from the circuit and it will drain in the effluent bag. This is the white color bag. White color line will connect with the this pre-replacement or citrate scale. So, okay, white in color, it will collect the citrate or pre-replacement from the bag and deliver into the before the dialyzer. Okay, I will show you where exactly it is attaching. Then dialysate will collect the dialysate from the dialysate bag and it will deliver in the dialysate compartment here. Okay. Then,
Green color.
yes, green color. Then in purple color we have post replacement line. So these 4 lines will connect with these color codings. Okay. Only these 4 lines and these 2 lines. Okay. Then we have a small line here for the heparin. If the anticoagulation is systemic, we will connect this line with this syringe pump. Okay. So now this filter which is coming not like this, in a neat way, like this it comes, sterile cassette. Now we are used for demo, that is why if your technicians they are using, tell them don't touch anywhere. Okay, so like this it comes. Now the first step is it's saying snap the cartridge into the carrier. So this is the carrier, this is the cartridge. Okay, here's the picture also there. It's cartridge. Here there are 2 holes. I'm connecting this with this carrier. Okay. The next step is saying attach all the pressure ports. There are 2 red color and 1 yellow color. So this is the yellow line in the pressure port. The pressure port is look like this. Then I will Okay, this is how we have to zoom in. Then here 2 in red color. Okay, pressure ports are connected. Next machine is saying snap the discharge ring. Okay, as I said, for the like earthing, we are connect this in this direction, yellow line. Then this is for the blood leak detector. Okay, in case the membrane rupture, that blood will detect from here. Then temporarily hang need a drain maybe to empty this because already I primed. So I will what it is saying, connect access line and effluent line with a Y connector. It's just a for the connecting. Okay. In HD also they have one white color connector. Instead of that we have this Y connector. Okay. And I ordered it. Next, connect the deaeration chamber. So this is the deaeration chamber to deaerate the circuit. So I kept here like this. Then the return pressure port. Then insert in the air detector. How to open it? Just press it. You can remove it. Okay. Then this is the clamp. In case air detector further flow need to stop. Okay, like that. Okay. Then I have to empty this. No other way. Okay, just give me to this.